we're still thinking Thursday. I don't think it's gonna be an issue at all. Yeah. Yeah, you get the note, you guys have your note card, and you guys will still use the laminate sheet, because like I said, there's no reason why you need to memorize product to sum to product, half angle, double angle. You don't need to memorize it, you just need to know how to use it, that's all.
Oh wait, we get the laminate.
Everybody but you. You have to put everything on your note card. I'm gonna cut your note card in half.
Oh,
Sure. Whatever.
You kind of need both sides.
Is this on our thing?
Yes.
No. You and Caleb are now taking the same test.
It's gonna cut you too.
Not at the same time, and it's gonna be just as difficult.
I'm just gonna write it.
I don't
Yeah,
see
exactly.
it.
All right, so we've got product to sum formulas. Again, you can use sum and difference formulas to get through all this. It's just another way to, for those of you guys that do go on into calculus and whatnot, they use these things with with integrals. And what happens with an integral, even if you guys take a stats class, derivatives and integrals, more so an integral allows you to find area underneath a curve, okay? It finds certain values. It has a huge significance within statistics. It's a very, very easy thing to use in stats. It's actually probably the easiest. It's like the one thing I remember from calculus is how to do integrals. But when you're working with it pre-calc, I don't know if we're actually going to get to a lot of derivative or integral stuff at the very end of the school year, but we might. But anyway, a lot of these things, if you take calculus next year or in college or not, you're going to see this part again. Hopefully you'll still be able to use one of these little laminate sheets because these formulas are a pain in the butt to try to memorize. But here's what happens. What we're going to be able to do is write as a product as sums. And it'll tell you this in terms of an instruction. It'll say, rewrite the product of cosine of 5x, sine of x as the sum or a difference, depending upon what the formula allows you to do. Yeah.
It's the function product relation.
Okay.
The functions, where is it? Function,
Function product relations or not?
Function, yeah.
yes.
Okay.
So as you go through these, it winds up being a lot of simplifying via the formula. So we have, this is the same as writing it out as sine 4x, cosine 5x, just so you guys remember you can go back and forth. Because I think the laminate sheet here uses the sine ones first. Excuse me. So we wind up with 1/2 when we write out the formula. 1/2, I just lost it here, sine. Where this is your x, and that's your y. That's really all it can do with this.
Why did you? Oh, never mind.
Oh, this is the different one. This is the cosine. This one not on here. Function. The cosine sine one is not on.
Yeah, it's moved on, right? Oh no, they just do sine cosine.
Oh yeah, they did. I didn't realize it wasn't on here. Okay.
But it's the same thing.
It's just got subtraction now. It's minus in the middle. Okay. I just realized that on our sheet here, on your laminate sheet, the cosine that one's not on there, the reverse of it. I didn't realize that.
So then I would definitely have one.
Well, if that one's on there, I'll make sure that.
It's on there.
Hmm?
It's on there.
Is it on there? No.
No,
Sorry.
like, she needs her.
I know, I'm just trying. It's weird. Anyway, so just to have it. It's on the laminate sheet. It's not on the laminate sheet, so this is the one for the when it goes cosine sine. We have on the sheet sine sine, cosine cosine, and then sine cosine. But there isn't a cosine sine on it. Oh, I didn't know. I found that very odd. Oh well. So at least we have it written down. It'll probably do the same. I wonder if it does the same thing with the product ones. Oh, it has all those. It has all the other ones going backwards. Yeah, I am. That's what I'm looking at. That's why I'm trying to figure out why it doesn't have it on there. Oh well. So we just substitute in then. You wind up with 1/2 the sine 5x plus 4x minus the sine of 5x minus 4x.
Is it, wait, so it's not
Minus 1/2 sine.
I'm just going right off the formula, guys. Okay.
Okay, so
Where
the
the x-
cosine sine is different than the sine cosine.
Yes.
Because-
That's why I wrote it out. So what's 5 plus 4?
No.
What's 5 minus 4? 1. So you get 1/2 the sine of 9x minus the sine of x. What's 5x minus 4x? And then x.
Yeah, but I just.
And now just distribute the half. Like I said, it's using the formula just to distribute through. You will see this more when you guys, if and when you guys take an actual calc class, because this is when they start to use it with the integrals.
And then that's it?
Yeah.
Oh, okay.
Okay.
That's easy.
Bless you. It's really all that is. It's just a matter of manipulating the equation again. Yes, it is. It's just simplifying out. Okay. And no one like that, I believe. No, I didn't have 2 of the other ones. Going the opposite direction is the sum or product. Now, all 4 of these are on here. I just double checked that one. All 4 of these are on here. What they did on
This sine is different.
okay, they have it as plus or minus. So they go plus and then minus cosine. So it goes plus, minus, and then if it's minus. Minus the sine times the cosine. Okay. So the way that they rewrote those two, they wrote it again with that plus minus. Notice that when you're working with addition to multiplication, does the order in which you multiply anything have any bearing on the problem? That's why they just changed the signs up. So that's why you see it as, on here, they have it as 2 sine 1/2 of okay. It'll say, yeah, it'll say on the example, with the prior, it said rewrite using product of sums. Rewrite using the sum of product. It'll say that. You know, it's just a matter of simplifying. So using the sum to product formula is what this does. And the other example of that one is this. Find the exact value using a sum to product formula of cosine of 195 plus cosine of 105. You're basically using that. Or the 195 and 105 are playing roles of x and y, respectively. So it's just substitution then again. 2 times the cosine, 195 plus 105, oops, over 2. Is it okay that I bring it over 2? 1/2 times the quantity, same thing as divided by 2? Yeah? You're finding the average. Cosine 195 minus 105 over 2. So far, so good. So it's Nacho Gouda. Anyway, 195 and 105 is 300. Half of that is 150.
I understand.
195 minus 105. Half of it. 150 has what as a reference angle? 30 degrees. 150 has a 30-degree reference angle. It's in the second quadrant. Is cosine positive or negative in the second quadrant? It's negative. What's the cosine of 30?
Negative 3 pi over 2. Yeah. Wait, not 3 pi over 2, just negative root 3 over 5. It's alright, it's Monday. We lost an hour of sleep.
I think it threw off my dog.
What? Oh, dogs are precious. Oh, I love dogs.
So, and my dog was up all night last night. She just kept barking, didn't want to sleep. I don't know. Anyway, so cosine of 30 is root 3 over 2. It's just negative because it's in the second quadrant. And then what's the cosine of 45? So when you multiply all this out, you wind up with negative root 6 over 2. And there's your exact answer. It's over 2 because the 2 divided by 2 cancels out. Cancels out one of them. Okay.
Oh, that makes sense.
That's how it's going to work itself through. I think I have another one of those. You should do what?
Start clapping after we finish your presentation. Did you hear something said?
It's like,
I hate when people clap at the end of movies and movie theaters. Like, when a place like no, I worship because the pilot did a good job clapping them safely. I always say thank you.
He's a nice
Thank you.
So then you step down.
He looks pretty sad.
I heard that he seemed to want to do it so he could take the phone.
We don't know what it meant.
Let's do this one. Same deal, sum to product. Let's do sum to product.
No, Mr. Murphy, what's her name? You know who I'm
No.
talking about. The lady that interviews the candidates. On
Oh,
Fox News.
No.
Annette Funicello. Sign. Some of the product. We do this, another example of the same thing we just did. Using Brady. So I've sine minus sine. So this is going to equal. Okay. According to the formula, that's what it does. So what's 5/4 minus 3/4? 2/4, which is 1/2. What's half of a half? 4. Okay. So you wind up with 2, and what's the sign of pi over 4?
Wow, I keep missing that. That's the second time that I've said that today.
Okay. What is 5/4 plus 3/4? 8/4, which is 2 pi. What's 2 pi divided by 2? What's the cosine at pi? -1.
So negative 2.
No.
Oh, because
Well, because the 2's drop. It's -1 times 2.
That's pi over 2.
Oh. Remember, you're just using the products, the formula. Okay. Now, obviously, the sine of 5 pi over 4, that's something we could have figured out. Okay. Sine of 5 pi over 4 is third quadrant, so it would have been -√2 over 2. 3 pi over 4. Use me. Is second quadrant, so you have minus the -3, and you wind up working it somehow. Okay. I think that was all that I had.
We should teach that.
I don't know if I had to do the cosine one. Did I have you guys do this one? Oh, the trig one. Let's do this one real quick. I think this is the last one.
The same thing.
Yeah, we'll solve it with the trig equation here. So when you're solving the trig equations like this, you have addition, and they want you. It's easier to break it into the multiplication then. All right. So you use the sum to product formula with the signs adding together. Okay.
Jeff, did you guys draw those SpongeBob pictures?
So
No.
2 sine.
Karen's good.
Good, because they look terrible.
We didn't.
Karen. I know, I've seen this.
What's 5 plus 3?
8.
Half of it.
4.
Go Madeline.
They're not pi. I don't have to say pi this time.
And then this one would be x.
That's it. That's all we have to do.
You just gotta solve for x still.
Oh.
Now, when you have the product of things, you have two separate terms there that you can set equal to 0. We have the 2 sign. And I believe these would probably be thrown into list all on the interval. I'm just saying it's on the interval between 0 and 5. That's all. They're not going to say general solution or something like this. Obviously, so this is where you have where sine is equal to 0. And then we have to tack on the pi. Remember how we did that with the pi n? Figure out where it goes when you have the 4x part. We had that. Oh, this one didn't. Sorry, this was not an interval problem. My bad. This was a general solution. So what angle gives you the sine of 0?
Wait, would they ever be in interval combination?
They could, but
Okay.
this one wasn't, right? What angle gives you the sine of 0?
Wow. Pi over 2. No. Pi.
0 and pi. So I know that this would be 4x is going to equal 0 plus pi n.
Okay, if it's a general one, you don't need it.
This is general, so this is. Because I
I
crossed
thought
out the
if it
interval.
was an interval, you needed.
No, all the way around. Because the interval, when it's on the interval, that means when you list every single one of them. If it's general, we do it with the pi n. Okay.
I think I got that clarified. Otherwise, I would have done it wrong.
So in this case here, in order to solve for the x, then you have to divide everything by 4. So it's just going to be 0 plus pi n over 4. Okay. And then where is cosine equal to 0?
Pi over 2.
Pi over 2 and 3 pi over 2. And that one I just do the plus pi n. Okay. Because that was just going to go from 90 to 270. We'll just go back and forth. I honestly don't think there are too many of those, if maybe one in the homework. I think that's all of them. I don't think I had another one.
Wait, don't you need to do the pi in for the rest of
I didn't need to do an extra divide out because it was just cosine of x. It wasn't like cosine of 3x or anything like that.
it? Okay.
So that's when you have to do. That's when you solve it like you would normally, and then just divide it by whatever that constant was. Yeah. All right.
Wait, why don't you use the resident?
It is.
Tells you 0.
Because pi over 2 plus pi n gets me to 3 pi
Oh,
over
right,
0
right,
and
right.
goes back and forth.
You list every.
So remember,
You need to learn.
okay. So if there's nothing there, it's a general solution. So that means there's going to be some pi n, and if there isn't, it's just list all. Okay.
Hey, can you charge this for me?
Sure. Or do you want a quarter?
No, you can. I'll leave it for me. Thank you.
Mm-hmm.